Well, hello everyone. Thank you for attending today's webinar, How U.S. state and local water agencies can benefit from using satellite imagery. My name is Amy and I'm the operations manager here at National State Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to know more on how information to get involved with us, please visit our website, www.nisjic.org. I will pop that into the chat box shortly. Some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A. So please place your questions into the chat box. They will be answered and the chat box will be read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the sure to look out for that. With that, I will now turn it over to the presenters. Thank you for joining us.
Hi, everyone, and welcome to today's webinar on water resource management. My name is Michelle Sisson, and I'm a Senior Product Marketing Manager here at Planet, focusing on U.S. state and local government. I'm here with Chippy Kislik, who's an expert in remote sensing for water resources. Chippy, can you share a little bit about your background and your role at Planet?
Yeah, sure thing. Thanks so much, Michelle. Hey, everybody, I'm Chippy Kislik, and I'm a pre-sales engineer here at Planet. Before Planet, I completed my PhD at UC Berkeley, where I was using satellite imagery in drones to study water quality. And more specifically, I was looking at algal blooms across California. So I really can't wait to dive a little deeper in our webinar today.
Great, thanks, Chippy. We'll begin with a brief overview of our work at Planet, and then we'll show several examples of how state and local governments can use Planet imagery for water resource management. We'll also provide a demo to show how you can use Planet imagery within one of our integrated GIS applications. And then we'll end with a preview of some of the newer capabilities coming online.
Planet is a leading provider of global near daily satellite data and geospatial solutions. And we believe that you can't manage what you don't measure, and that collecting data about Earth more frequently can help address a wide array of global challenges. Our mission has remained the same since Planet was founded in 2010, to image the entire world every day and make that information visible, accessible, and actionable to everyone. Today, we operate over 200 satellites in 2 different classes, which scan and image the Earth on an average of 300 million square kilometers every single day. And the first type of satellite is our PlanetScope Super Doves, which are about the size of lunchboxes. And they fly in large constellations to map the Earth's landmass at about 3-meter resolution. We also have 21 SkySats in orbit, and these provide responsive tasking multiple times a day at about 50-centimeter resolution. This combination of different satellites with different sensors allows our customers to detect changes at roughly 3-meter resolution with the PlanetScope, and then zoom in by tasking follow-up observations with the higher resolution SkySat satellites. And we downlink and process 4 million images per day and serve that data to customers through a data subscription model. And all of the water-related use cases that we're going to be discussing today come from PlanetScope's SuperDove and Dove satellites. And these offer near daily imaging at about 3-meter resolution. The PlanetScope analytic data products are calibrated to Sentinel-2 and can be easily integrated with current GIS applications. So if you're familiar with ArcGIS or QGIS, those are some of our integrations, as well as other public satellite imagery like Landsat and MODIS to ensure that you're getting the specific insights your department needs. And one of the things that Planet does really well is provide near daily imagery. So to illustrate that, we're first showing you imagery that's available over a plantation in Brazil using Landsat 8 and Sentinel-2 imagery. So that's what you're seeing here. This is a really cloudy region, so even some of the available images are not always useful. So here it looks like we have maybe 1 or 2 usable images throughout July 2021. And here is image availability of PlanetScope and SkySat over the same region in Brazil in July 2021. So there are still a lot of clouds, but the image availability increases from maybe 1 or 2 images to 10 to 11 images. An increased frequency is incredibly important for water resource management when events occur more than once or twice a month. So for example, Planet Imagery provides flood management response teams with the latest coverage that they need to respond to these types of emergencies. And also, Planet Imagery is useful in informing local agencies about the dynamics of toxic algal blooms that might be spreading across a water body. And additionally, one of the benefits of near daily imagery isn't just that you're getting an image every day. It's that more data improves greater confidence in the values. So having 5 well-calibrated observations in a row within 1 week can really help enable water managers to trust the data and understand when anomalies might occur, and that can help them better make decisions and better act, and faster as well. And last year we added 4 new bands to our PlanetScope SuperDove constellation. And those include the coastal blue, an additional green, yellow, and the red edge band. And these additional bands are especially useful for monitoring watersheds and coastal or riparian habitats, as the coastal blue band is great for bathymetry, green can be used for vegetation health, yellow for cyanobacteria assessments, and red edge for water quality. Our 8-band data is available across APIs, our GIS integrations, and our user interface called Planet Explorer. And we're going to share a demo of how to use these tools together later in this webinar.
Great, thanks, Chippy. So now we'll show some examples of how state and local governments can use Planet Imagery for water resource management. And what you see on the screen are some of the most common applications of Planet Imagery for water resource management. And as you can see, the opportunities are super broad. And across all of these use cases, we've seen that state and local governments have a few key needs that are really front of mind. First, agencies want to see changes that occur in near real time and in detail. And that's why we capture 4 million images every day. Our constellation makes it possible to detect detailed changes over time and over large areas. Second, GIS departments don't want to waste time processing data. Planet data is pre-processed, which frees up time to dive into the analysis. And third, agencies want data to be more accessible across departments and to different skill sets. So we're building a software stack on top of our data that makes it as easy as possible to extract information that powers decisions and action. And this is especially important when it comes to coordinating interagency work. So now we'll walk through a few specific examples of how agencies can use this data. The first area we'll talk about is disaster preparedness and response. So here we're looking at a PlanetScope image of Midland, Michigan in 2020, just before a period of heavy rain. This is what it looked like 1 week later, after the area received 4 inches of rain in 1 day and 2 upstream dams failed. Now, the flooding was caused by a combination of factors, including aging infrastructure, intense rainfall, and a sudden loss of soil strength of an embankment. And while we're looking at what is probably the most dramatic outcome immediately following an event, Planet Imagery can be used throughout the entire disaster management lifecycle. Before events, it can be used to reduce risk and plan ahead, such as modeling flood events, monitoring soil water content, and even monitoring construction or permitting of infrastructure projects. During events, Planet Imagery can be used to improve response time, assess damage or road blockages, and allocate on-the-ground resources, and after events to rapidly estimate damage totals and monitor recovery efforts, such as revegetation or repairing of infrastructure. Here's another example from Florida after Hurricane Ian in late 2022. And you can see very dark freshwater filled with dissolved organic matter flowing into the Gulf of Mexico. In this case, the hurricane caused a major runoff event, which posed risk to marine life, fisheries, seagrass habitats, and also increased the risk of harmful algal blooms. So our satellites pick up a lot more data than you can see here, and the frequency of the data collection is what helps agencies track the progression of many types of change in dynamic coastal areas. In this case, planet imagery could help multiple agencies such as emergency management, natural resource agencies, fish and wildlife, and public health assess risk and track recovery. So many agencies use planet data to monitor the health of coastal ecosystems. This is an image from Point Lay, Alaska. Residents are mostly Alaska natives whose livelihoods are threatened by thawing permafrost and coastal erosion. And even the marine life is changing here. You can actually see it from space. Researchers have been able to monitor walrus populations using planet imagery. Planet brings a broad set of opportunities to evaluate historical change, protect natural resources such as wetlands, and monitor threats to coastal communities and marine habitats. And where water is really scarce, our imagery can also be used to help monitor and allocate water resources to residential, commercial, and agricultural users. This PlanetScope image shows fields along a stretch of the Sacramento River south of Anderson, California on May 31st, 2021. Here's an image from the same day in May 1 year later. Fields which were green in 2021 are now light brown due to a drastic reduction in water deliveries. The Planet data can help quantify water resources in areas that are highly prone to drought, improving the reliability of the data used to make key decisions on water allocation. And our surface reflectance base maps make it possible to measure vegetation density and observe plant health, which can actually help allocate assistance to growers who lose their crop due to drought. So now we'll hear about a few more examples from Chippy.
Great, thanks, Michelle. So this is an example of a time series of Lake Isabella in California, ranging in water levels and water quality, especially as you see some of those green portions of the lake in the later summer months. So with Planet imagery, we can measure reservoir storage capacity and water quality nearly every day of the month. We'll be taking a closer look at this specific lake in our demo in a few minutes. Here's a study that assessed lakes in high altitude regions. So you can see the changes in water availability with PlanetScope imagery, revealing that this landscape is much more variable and potentially emits more greenhouse gases than we originally thought. Planet data are readily available for water supply studies, and this analysis was published within months of observations. Here you can see images of Lake Erie, which is the shallowest and warmest of the Great Lakes. So we have an image before, so this one's July 27th, and then we'll show July 30th after an algal bloom. And in 2014, a toxic bloom in this region near Toledo, Ohio, caused a 2-day shutdown of local drinking water. So this image is 3 days after the previous one and shows the green portions of the algal bloom streaked across the lake, very visible to the eye. Water quality, and particularly algal blooms, can change within days and even hours. So it's really important to be able to monitor as frequently as possible. Planet's 8-band medium resolution data unlock new opportunities for monitoring water quality and algal blooms, including the ability to map maximum chlorophyll index with the red edge band. And here's an example of different spectral indices that were applied to 2 reservoirs in the Klamath Basin in Northern California. You can see the regular image, just the red, green, blue, in the top left. And these 2 reservoirs had very high levels of both chlorophyll A and even a cyanobacteria toxin called microcystin in August of last year. The top 2 images to the right show a way to perform a water mask, so that isolates the water pixels. And in the next row, we explored how we can use the yellow and the red edge bands, so 2 of the newer PlanetScope 8-band imagery to highlight this very, very high chlorophyll A concentrations in the eastern reservoir, while the normalized difference vegetation index in the bottom row appears to highlight lower concentrations of chlorophyll A. So with Planet data, you can do a variety of spectral analyses that are very specific to the characteristics of the water body that you care about. And speaking of a water body that we care about, Let's switch over to a recording of a technical demo of Lake Isabella in Southern California. We'll explore both the lake levels and water quality monitoring with Planet data. So now we're going to go through a short technical demonstration of how we can use Planet data for water level and water quality monitoring. So first, I'm going to show you how we can use Planet Explorer, which is one of the user interfaces that you might be familiar with. And there are many different ways to access our imagery. And this is Planet Explorer. Some of you might be familiar with it. Just to give you a quick example of how to download imagery, you can upload your area of interest right here. If you can follow my mouse on the right side. So you can upload files. There are very different types of file types, including shapefiles and GeoJSONs. So once you upload that, you'll see this bounding box appear. And then you can go over here in the filter region and you can search for PlanetScope scene. You can search for the area is 100% of the bounding box. You can have very low cloud cover, and you can make sure that you're only getting surface reflectance, just as examples. You can apply these filters, and you can also sift through different dates here. So you can go from maybe just the past month or so, and you can highlight that. And then once you select an image, you can order the scenes here. And then as you go through the delivery options, you can give it a name. You can be more specific, of course. And then here we have a couple different options for download. So the 8-band is what we're going to be exploring in some of the imagery within the past year. And in imagery that's a little bit older, you have access to the 4-band. And so once you click through that, you can decide which you want to use. You can just download this last scene if you want. It'll clip to your area of interest. You click order, and then you'll be able to download that image. So that's just one example of how you can use our user interface. Now I'm going to show you for the rest of the demo, all in our ArcGIS plugin. So if you're able to download the Planet ArcGIS add-in, then you'll see this little band here at the top, Planet Imagery, will show up. It's free and available to use for anyone who has an ArcGIS Pro license. And you can do an image search just the way that we just did. And you can use the same filters. So we can basically replicate that process that we just did here, changing the date, changing the area, the cloud cover. You can also upload your area of interest, similarly to what we did there. And when you search for it, you'll need an area of interest. So for now, we'll just click the extent, and then we'll search, and then the same process will happen. You can add different images to your map. So we can do that, and it'll show up in our contents pane. And you can also download imagery straight through ArcGIS Pro. So that just helps streamline everything a little bit better. So going into our contents pane, you can see that that daily imagery just showed up right here. So it's not downloaded, this is just streaming, and it will disappear the next time we open ArcGIS Pro. But today we're going to focus on Lake Isabella, which we saw briefly before. This is in Kern County of Southern California. This lake is very popular for activities like fishing, boating, and windsurfing. However, there have been a lot of water quality issues, including toxic algal blooms and lake level decreases prompted by drought. They had their driest year in 2015. So water quality and water level issues have hindered a lot of popular activities on the lake. And the county's Public Health Services Department monitors the lake for toxic blooms, specifically blue-green algae called cyanobacteria. And they found very high toxicity levels in the summers of 2019 and 2020. So with the water levels and the water quality issues, this makes Lake Isabella a perfect place to monitor using Planet's satellite imagery. So let's take a deeper dive. So to bring in imagery, for anyone who's not familiar with ArcGIS, you can go to the Map tab at the top, click Add Data, And then you can go and find your imagery that you've already downloaded. And we'll find some just as an example. I separated them between winter and summer months. And when you click into the file itself, you're going to download, you're going to bring in one of the images that says the surface reflectance clip if you selected that file. This next file is a user data mask. And so you can use that if you want to know percentages of shadow, haze, cloudiness, if you want to mask out any pixels. So when you do that, you click OK to bring in the imagery. And now we can investigate water levels and water quality. And the way that we're doing that is by different spectral indices. So what we talked about previously. So just looking through our imagery, we have images from February of 2020 through 2023. And if we just look for a minute, just taking visual notice, then we can see just between this is 2020 and this is 2021, we see a very large decrease in water. And from 2021 to 2022, there's even more of a water level decrease. And then from 2022 to 2023, it looks like the water increases again. So we have variable water levels. And if we wanted to be able to track this using spectral band combinations, you can highlight the image and then go up to the top tabs, select Imagery, and then in ArcGIS, there are several different indices that are available through this program. And in this example, we're going to be using the modified normalized difference water index. So that's going to isolate the water pixels. If you click on that, you have two options. So for the green band, you just click it and select green. For the shortwave infrared band, our PlanetScope imagery does not currently include that. However, for the water index, you can also use the near infrared. So instead of the shortwave infrared, we're going to use the near infrared. And then you can just click OK. And that's what I've done here in our normalized difference water index. So I've done that for all of our images. And we can see the water pixel values being highlighted in the brighter pixels. So anything that's closer to a water pixel will have a higher value. So we can see that, again, this is 2020, which had a lot of water for that year. So we can see that that Lake Isabella is pretty filled up. And as we click through, we can see that, again, it diminishes in 2021, even more so in 2022, and then seems to get a little bit more water just in the past month in February of 2023. So this is one way that you can use spectral analysis to look at water levels using the green and the near infrared bands. And if you wanted to be able to quantify this, you can use a tool called the conditional tool or the con tool. And we can take a look at, once you select different threshold values, you can use this to actually try and just identify the lake pixels. So this is what we've done here. And once you start to quantify the lake pixels, you can start doing change analysis from year to year. You can automate that entire process and see percentage of lake area and how that's changing. So that's one way that we can look at water levels within Lake Isabella. And as we mentioned, Lake Isabella also suffers from toxic algal blooms. And these usually occur in July, August, and September. So warmer months, you have warmer water, a lot of nutrients coming into the system, and a lot more algae is able to proliferate. So looking at some of the summer months, we have August from 2020 until 2022. So in August 2020, we can see there's a big algal bloom. These streaks of green really show that visibly. And that was what was reported from 2020 as well. Very toxic bloom. And then it looks like as we go to 2021, there wasn't as much of a bloom that's visible to the eye. And 2022, that looks the same as well. And so one spectral index that people use for water quality is the normalized difference vegetation index. Very, very commonly used in terrestrial studies, but also used for water quality studies when the water quality is right on the surface of the water body. So doing kind of the same thing we did here, you can highlight the image, go to indices, and go to NDVI. And this uses the near infrared band and the red band. So once you click OK, I've already done that here, we can take a look at what the NDVI values look like and if they're actually identifying some of the water quality within the lake. So here you can see our NDVI value for 2020 did seem to really pick up those big green streaks across the lake. So this worked very well. And then for 2021, we would expect not many streaks since we didn't see those in the imagery before. So that looks consistent. And same for 2022. And no blooms were reported in terms of high toxicity for those years either. So these are just a couple examples of how you can use planet imagery and spectral analysis to look at both water levels and water quality. And this is really useful for water managers who are going to the field and taking water samples, but need a bit more of a historical record to see a time series of how the lake is changing. And this also reduces those water managers from needing to go to the field as frequently. So fewer boots on the ground saves a lot of time and money, and also reduces potential a public health risk, since some of these algal blooms can have aerosols that can be potentially harmful to people who are around the lake. So now we're going to get back to the webinar and we'll talk a little bit about more how you can access these types of data.
Great, so thank you so much for watching the technical demo. And if you're interested in downloading the Planet data, we have several different ways of doing that. Many people enjoy using the user interface, Planet Explorer, which is what you saw at the very beginning of that technical demo, to view imagery and then download or host data on the platform. We also have QGIS and ArcGIS plugins. We just saw the ArcGIS plugin. So if you're familiar with these programs, you can find and download data directly within these interfaces. And finally, for those who are more comfortable coding, we also have command line and Python-based APIs to access, process, and download data. Looking ahead at future missions, we have a very exciting hyperspectral sensor that will be useful in water quality management. Coming up later this year, we will be launching a new hyperspectral mission that will enable new capabilities in the natural resource management world. We're extending past the visible and the near infrared and into the shortwave infrared to analyze things like water quality, vegetation health, land use, methane, and carbon. And in terms of water quality, hyperspectral missions have been used to understand which specific types of algae are involved in blooms, which can be really, really helpful in identifying when blooms are unsafe and potentially toxic. And for those who are interested in working with hyperspectral data now, we have an early access program that you can sign up for and gain access to synthetic hyperspectral data over Denver. So feel free to sign up on our website. We hope you enjoyed learning how state and local agencies can use Planet's near daily imagery for water quality, disaster management, habitat monitoring, water conservation, and to protect public health and safety. Here's our contact info, so please reach out to either one of us if you have any questions. Thank you so much.
Thank you, Michelle and Chippy, for this wonderful presentation. Now we will take questions. If you'd like to have a question, please place them in the chat box and they'll be read aloud and be answered by the presenters. I have a question. How can this be integrated with data that's collected in the field?
Yeah, Amy, that's a really good question. And this is something that I explored during my PhD when I was at UC Berkeley, looking at several different reservoirs within California. You can use satellite imagery from Planet, especially the PlanetScope 8 band is really useful. And if you have images around the same time that in situ or field measurements were taken, then it's possible to connect those data sets, maybe, for example, through running regressions, linear regressions, or depending on the type of relationship it is, because we can really collect, we can find a proxy for that chlorophyll A. And if you have that measurement in the field, then just finding it, seeing if there's a solid relationship between the two can help you understand the data and kind of if you can trust the relationship.
And what should I do if I'm interested in accessing Planet data? Like where could I go to learn more about that?
Yeah, good question as well. So I'm on the sales team. I'm kind of a technical person within that process. And we have sales representatives and account executives who help with the sales process. And you can reach out to me or contact sales through our website if you're interested in accessing the data. And we'd be happy to chat with you.
We did have one question from Shauna Ray. She's asked, is there a way to provide the recorded demo that was put on the during the presentation? Is there a link to see that or access to that? She made a note it was a little pixelated, so kind of hard to see.
Yeah, we can send that to attendees after the webinar.
And then Phil has asked, does Planet or its publisher, or excuse me, or its partners publish derivative products, e.g. annual river flow performance analysis results versus providing the raw data to do the analysis yourself?
Yeah, that's a really good question. So right now we have a couple derivative products, but they're a little bit more specific to terrestrial processes like biomass proxy, land surface temperature, so and soil moisture as well. But I'm very interested in trying to think of a little bit more water quality or hydrological variables. So it's possible that those could be incorporated in the future, but at least for the specific variables you're asking for about now, we provide the imagery, and then that's the raw pixel values or surface reflectance values that you can use within your studies.
And Mickey asked, in addition to imagery, does Planet provide analysis services, for example, a routine HAB monitoring service during summer months for a particular water body or coastline? Oh, okay. And then he said Phil beat me, so I'm guessing it's a similar question.
Right, yeah, so I would love to see routine HAB monitoring. That is something that you could, through the APIs, plug into a user interface or ArcGIS Online if you're using that. You could use our monthly base maps, or depending on how frequently you need the data near daily, the PlanetScope provides that. So that is something that can be worked into an integrated system, but we don't currently provide routine HAB monitoring right now.
All right, that looked like that was the last question in the chat box, but We'll give folks another minute in case anyone else would like to ask any more questions. And folks, I'm also happy to provide Chippy and Michelle's contact information if you'd like to follow up with them. And like they mentioned, we can also send out that recorded demo when we send out the webinar recording. So that way you have a copy of that as well. Is there a price difference with older imagery versus more recent? Mickey asked.
In terms of PlanetScope imagery, that is a bundled product. So with PlanetScope, it's all the same, but with SkySat, which is the 50 centimeter, we do have SkySat archives. So that's past imagery that's already been tasked by other people, and that's a different price than tasking it yourself and asking the satellite to point to a specific location. But in terms of PlanetScope, that should all be the same.
Give folks 1 minute. Well, I think that was the last question in our chat box. Michelle and Chippy, I want to thank you so much again for coming on today to provide this wonderful webinar. It was very interesting. Would you like to say any last words?
Thanks so much for joining, and feel free to reach out to either of us individually, or you can always contact sales through our website. If you've got something in mind you have a lot of curiosity about, please don't hesitate to reach out. We'd love to help.
Yeah, and if anyone has questions about the recording, the technical demo, definitely reach out. I love chatting about this stuff, so it would be great to hear from you.
Well, thank you to you both again for this wonderful presentation. Just a reminder to folks on here, there will be a recorded version of this webinar. So keep a lookout in your email, and I will be sure to include the recorded demo that these two wonderful ladies have provided. And thank you to the audience for joining us today. We all hope you enjoy your Thursday afternoon.